back into the universe in a phase known as reheating.
Per second. A trip to New York to Los Angeles at that speed would only take half a minute. The disk of Andromeda can already be seen with the unaided eye on moonless nights. As time goes on, it'll get even bigger. As Andromeda gets closer to us, its gravitational force will begin to stretch the arms of our spiral galaxy. It'll begin to unwind. The stars and planets will lose their orbits. One possible scenario is that an unknown asteroid, or even a dwarf planet from the Andromeda galaxy, will crash into the Earth at an incredible speed. Our planet will explode just like a balloon from this impact. Oh, goody. Another option involves stellar collisions. Our sun would face another star. The bigger star will slowly begin to consume the smaller one. First, it will steal the light upper layers from it, and then it will eat it just like spaghetti, or even like rigatoni. When a large star reaches its critical weight, it will burst. This explosion will destroy everything around it, including our solar system. Perhaps the shockwave will even reach other neighboring stars. Yet another scenario is that our solar system will be thrown into dark space. Imagine a tennis ball tied to a rope. You take the rope and spin the ball over your head like a sling. Then you let go of the rope and send the ball flying. This is what will happen to the sun and all the planets around it. We'll find ourselves in dark and cold space. But life on Earth will not be affected. We'll still have our bright star to keep us warm. The only disadvantage is that all the stars in our night sky will disappear. And the most likely possibility is that the merger of two giant galaxies will have no effect on us at all. The thing is, the distance between stars and planets in space is enormous. So they can all just mix together and form one giant cloud. It would be like shoveling fine sand through a big sieve. The objects won't interact with each other. But the most interesting thing will happen to the black holes in the centers of our galaxies. Right now, there's a dense cluster of stardust and stars around them. As Andromeda and the Milky Way come closer together, they will begin to dance with each other. Gee, will it be the twist or the foxtrot? And when the black holes get close together, they'll begin to swallow all matter around one another. Billions of tons of colored
Being that could somehow look upon it from the outside world would clearly see yesterday, today, and tomorrow happily coexisting. But where did this all come from? As with everything else, scientists believe that the Big Bang birthed all of space-time. In other words, all of space and all of time. The regions of time we refer to as the past, the present, and the future are all there together in their entirety. And so it's as easy for two people to exist then and now as they do here and there. They can be separated by centuries of time, just as they can be separated by kilometers of distance. Any object within this block universe can be given 4 coordinates. 3 spatial to say exactly where it is, and 1 temporal to say exactly when it is. Imagine that an object's location in the block is marked by a dot. Even the dot of a physically stationary object moves because its time coordinate is constantly changing as second ticks after second, and today relentlessly becomes tomorrow. Join all the dots belonging to one particle, and you have a line that maps out its path through the block universe. A world line. And the world's very first time machine is sat, buzzing before you. Only then does the penny drop. How had you never realized before? You now have the power to go anywhere and any when, but you know exactly what you have to do. You take the letter you've kept all these years out of its frame on the wall, place it back inside its original envelope, and put the envelope in your pocket. Stepping into your time machine, you set the controls to take you back to a cold, moonless, misty night, arriving just in time to push your younger self out of the path of the onrushing car. You die on the roadside.
Ouch.
It seems simple enough. But the real joy of time travel stories like this one comes once you begin to scratch beneath the surface, and some incredibly profound questions begin to emerge. First of all, who wrote the letter? The older version of you simply takes the letter they'd already been given as a teenager back in time. The letter is a seemingly creatorless entity stuck in a time loop. This is the bootstrap paradox. Secondly, do these time loops keep on repeating? You save your
What are the
teenage self,
bootstraps?
so they grow up to travel back in time to save their teenage self, who grows up to travel back in time, and so on. You are stuck in a relentless cycle of living and dying.
Oh.